Hi, my name is Nick Marchuk, and this is my remote presentation for TEACHx in 2021. My talk will be about using the Lab in a Backpack kit as we went remote in 2020 and 2021 during COVID. Again, my name is Nick Marchuk. I'm a senior lecturer in mechanical engineering at Northwestern. I teach in the mechanical engineering department, as well as the biomedical, electrical, computer science, and in Siegel, our design school. First, what is a lab in a backpack? My lab is the mechatronics design lab in the basement of Ford next to the machine shop. And it's a typical electronics lab with benches that contain power supplies, oscilloscopes, function generators, multimeters, and lab space where students can build circuits and test and debug code. This kind of space can only support so many students. So back around 2010, Michael Peshkin in mechanical engineering decided to try to flip the lab-style classes in electronics in mechanical engineering and develop a kit so that students could bring the tools that they need with them wherever they go. That turned into a style of class that you see here, where a student could sit in class, one of the larger classrooms in tech like M345, with a box a little smaller than a shoebox that could fit in their backpack, and has a USB-powered oscilloscope, power supply, and function generator that we call Nscope. In the box, they would also have the tools and the components that they need to build electronics. And then in class, they can follow along with a short lecture and then start the homework. And then at home, they can build, debug, and document circuits. And it becomes a very hands-on, fun style way to learn this style of electronics. Over the course of several years, we developed this into a standardized kit that is called Nscope. And I started a company with a graduate student named David Meyer, and we did a Kickstarter, and Nscope's now a product that is used at a variety of schools across the country. And we use it in the mechanical and biomedical engineering classes at Northwestern quite a bit. Michael Peshkin coined this term lab in a backpack, and it's become a really popular style of teaching for our students. We've been able to bring this to many schools around the country and now around the world. Here you see in the middle, we went to University of Lagos in Nigeria in February of 2020, and Michael Peshkin in the middle there is demonstrating the use of a small light board. So these are professors who are interested in learning exactly how they could bring lab kits to their students who don't have access to the large supply of oscilloscopes that we have at Northwestern. Right after we got back from Nigeria, we started to go into lockdown, and I had to start to think about my spring classes, which are also hands-on lab-based classes. And the challenge there became, how will I be able to support my students that typically in class can raise their hand and ask questions at any time, and during my office hours can bring their components with them, and after their questions are done, they can take their components home and work on it, but know that I'm still there to answer questions, and they could bring all their things into class, and the live lecture is very interactive. So the immediate problem became, how do we supply all of these kits to the students? So this is my living room, and it took a pretty good amount of thought to think, well, what is every single component we might need to ship to our students so that they can build circuits and test at home without being able to come and resupply from the lab. Typically, I would give the students half the components up front, and then each time they come into class, they could grab more things and they could refresh their kit. So first, we had to just find and source all of these components during the early days of the pandemic without any resources like the loading dock from the school, get them to my apartment, rearrange them, and put them in boxes. It was quite a few boxes. I think I had over 150 students for the spring. My dog was very upset that we could not get them out of her favorite sleeping areas. And just the scale of thinking that every kit needs maybe 50 to 100 components, and getting them all in some kind of packaging that could be shipped, some cases internationally. And then for the students who were in Evanston, I was able to bring the kits to a parking lot and say, sign up for a time to come get it from my car, just fitting this sheer volume of components into my car was a challenge. And then rather than drop off the boxes that were going to be shipped to FedEx locations, I went to the shipping center in Niles and dropped them off directly to minimize delays. And FedEx said, just leave it on the sidewalk and we'll come get it. So that ended up working great, but a little scary leaving all these paper boxes outside when it could have rained. So we learned a lot of things about making the kits and getting them out on time with only 2 weeks notice. The time investment in packing the kits is really immense. I think I spent over 40 hours just sourcing the parts, and then once they came, cutting them up into little baggies and resorting all the baggies and just figuring out who needed what part and labeling. What was a huge amount of work. Then different departments seem to have different favored shipping services like UPS, FedEx, and DHL. They all had good deals, but it was unclear why the different departments were using different services. The domestic shipping, using the NU discount was very reasonable. Initially, we shipped with USPS, and around $10 for that kind of size of box was a good deal, but sometimes would take a week to ship. FedEx and UPS were doing, for the same price with the NU discount, shipping in 2 or 3 days. International shipping, which I was quoted as an individual between $100 and $170 for each package, became very reasonable with the NU discount, somewhere around $30 or $40. So that was still very doable. The downside to the international shipping, though, is that no one seems to understand how to fill out the customs forms and put down the proper information for a VAT. We had some students report that the customs forms were not filled out correctly, and they would get stuck in customs for several weeks. And some countries have 100% value-added tax, VAT tax. So they had to pay the complete value of the components that were in the kit to be able to get it out of customs. But we had several packages go to the same country, and some went through with no problem, and some got stuck. So definitely the customs officers, some are doing better jobs than others. That's something that should definitely be sorted out if you have a lot of international students in your class and you want to ship them things. So once the students had the components that they needed to be able to take the class, we needed to develop some tools to be able to teach them properly. Specifically, when you're doing this kind of hands-on class, it's nice to be able to look over their shoulder and see exactly what they see so that you can try to guide them in how to debug and evaluate what's going on. So here we see a document camera developed by Michael Peshkin using a small acrylic mirror and a piece of wire that sits on top of the screen of a laptop and redirects their webcam down towards their keyboard. And that way the students who are provided with a notebook and a pen, just in case, could draw out their circuit diagram and show us the circuit that they were building just by laying it on top of their keyboard. This works out pretty well, and if you go to this tiny URL, you can request one of these mirrors because we made thousands of them, and they're available for every class at Northwestern. Here's another view that shows you the mirror hanging off the front of my laptop. So to be able to do lectures and office hours, I wanted to develop a higher standard of teaching than just using my little mirror camera, although that worked out pretty well in a pinch. But I built a mini lightboard studio in my second bedroom. So here we can see a lightboard studio, also made by Michael Peshkin, is a piece of glass with some white LEDs surrounding the edge, so that when you write on it with a neon whiteboard marker, it really pops. On top of that, I built an aluminum frame around it to hold it. And I've got 2 cameras. I have a face front camera to record what I'm writing, and I have a top-down camera to show what I'm doing with my hands. Then I have a Yeti microphone for high-quality sound. And so I can write on the board, and I can switch to building with my hands, and then I can do screen capture to show what my oscilloscope would see. Here's a view from the face forward camera. Note that the text is backwards, so in post-processing or some other technique, you would need to flip the image. And then here's the top-down view. I have a 300 millimeter zoom lens on this camera so that I could really zoom in and see exactly what's happening at the 0.1 inch scale on my breadboard. So here's an example of a video I made teaching op amps using what looks like the Lightboard Studio on campus. It's just a little smaller. It's I probably get 3 by 2 foot usable area. This style of video, you really have to think, what do I need to write? Because it's very difficult to erase the style of marker. So you need to teach and write within usually around 4 minutes. But that's good because you usually want to keep your lecturing videos to 4 to 7 minutes. Otherwise, people start to drop out. So this size is not really too bad, although a marker with a finer tip would be helpful just to keep the text a little more clear. Using the top-down camera, I tend to make longer videos because in this style video, I can write on a pad of paper with a Sharpie, and then I can show the circuit that I'm building, and I can flip back and forth. And then I can add in screen capture. So as I'm building my circuit, I can show what's happening on the oscilloscope, and then I can go back to the circuit and add a little bit more circuit and kind of lecture as I build up these circuits. To capture all of this video information, I use Open Broadcaster Software, or OBS. This is an open source package that works really well in Windows and Linux. Mac too, although capturing video in Mac is also good in QuickTime. OBS is really nice because you can have several scenes going at the same time and a little slider bar that says which one do you want to show on the screen at any time. So I can flip back and forth between screen capture or video capture. Eventually, I also learned that I could add some equalizer on my audio, which really improved the quality of the audio. That came from a company called Reaper. I post all my videos on YouTube so that they're easy to find for the students and they can easily go from a laptop to a tablet to their phone if they need to watch on different sources. And it was interesting to see the analytics that YouTube collects. I could definitely see a pattern in my Monday, Tuesday class, and right now my asynchronous class where the students seem to watch whenever they want. Midway through the spring term of 2021, I was teaching around 150 students in 2 big classes and then more students in smaller classes. I sent out a video survey to see what the students thought of my video collection capability and what could I do to improve. My main concern was that the audio wasn't very good. So here's the response to rate the overall sound quality of the videos. And most of the students thought it was okay, but it was a very linear slope here. And the comments were mostly saying that it was too quiet. So even on their maximum volume, sometimes they couldn't really hear me. And in the background, I have steam heat in my apartment, and so randomly, sometimes the steam heat would turn on and add some hiss to the background. I have no control over that, so I sometimes just turn off the video and wait, and other times just have to power through it. So this really led me to find better equalizing capability for my microphone, and software really did that in Reaper. The image quality the students thought was pretty good. But a few comments said that it was low resolution, and then my typical inability to write very clearly. And quickly I discovered from that was that OBS was not recording at full HD, and it was just a click of a button I needed to get full HD, and that made the quality even better. In YouTube, I had automatic closed captioning turned on, and around 20% of the students were using that. From my experiences taking online classes, I typically speed up the video. I asked my students if they were doing that, and a little bit more than half were doing that. So I made this summary, and I sent this to the students so that I could address some of the issues that I was seeing. I was able to, using the EQ and some other functions from Reaper, and vastly improve the quality of my audio. I was able to increase the gain but not increase the background noise. And that makes the video much, the audio much crisper, although sometimes there's a weird distortion when I go from silence to speaking. The T in that might have been rounded off. I figured out how to get my videos in 1080p. Of course, the file size is much larger, but everything becomes much crisper. Some content that my students suggested was even short videos, the 4-minute videos, could still use an intro and an outro. So at the beginning of the video, what are you talking about? And then talk about that stuff, and then end by reiterating what was this video about. The students also wanted some more real-world examples. So even though I was doing hands-on things in my videos, they still wanted to know, what were we doing? Why were we adding buttons? Why were we adding sensors? How could they use this in some of their project-based classes? The students who were using closed captioning said that sometimes it wasn't very accurate. And I don't know if that's because of my weird New Jersey accent, sometimes coming in and out, but definitely speaking slower and trying to pronounce as neutrally as you can increases the hit rate of the closed captioning. I've also figured out how to add timestamps to videos so that if you go below a video on YouTube, there'll be little hash marks and people can jump directly to new topics within a video. But in general, it's a better idea to make shorter videos and more of them rather than a video with many different pieces of content in it. So my thoughts on this is that a sound studio is very hard to build, especially when you don't have control over your heat. Open Broadcast Studio is very good for getting all this data in, but every video capture device you need, going from HDMI on a camera to USB, requires a real USB 3 port. My laptop only has one, so I generally only have one camera source at a time. And sometimes I really think that the sound doesn't match up with my lips, but people tell me that that's just in my head. So I'm not sure about that. Next time, so it's around midterms of the spring quarter, I'll probably add some more questions to a similar survey, asking them what they think of the length of the videos, do they end up watching the whole video, and how many times do they watch the video? Well, I can kind of see that in the YouTube analytics. It'd be good to hear from the students and see if they have any thoughts on that. I also generally have 50% face-forward videos and 50% top-down. I want to know if they prefer one over the other. After the winter quarter ended, we had lots of CTEC responses from the BME class, which is more of a standard lab class, and the mechatronics class, which is more of the lab and the backpack style class. These comments are from the BME class. I feel like the first one really sums it up. The labs are pretty fun to do sometimes. So the students really sometimes have a lot of frustration in this style class. They're building a circuit, but when something stops working or they can't get to the next part, they're really stuck, and they can easily waste hours tracing through, debugging, and they just can't figure out why it's not working. But with an experienced eye, I can look at their circuit and tell them within a few seconds, what to check or what's wrong. So in a classroom setting, they can raise their hand, I can come over, I can look at it, I can give them a little hint and walk away, and generally things keep moving. But when we are remote, and if they're not logging into office hours or during the assigned lab time, they're working at home, they can easily get stuck and then rack their brains for hours and hours, and the class is just no longer fun. So in general, they really like the labs because it's very invigorating building something and then getting to see it work, especially in the biomedical engineering sessions. They were building sensors that could see their heart rate, they could see their EKG, they could see EMG, things that really make the BMEs tick. But getting stuck, of course, is not fun for anyone. Students really like the recorded lab lectures and lectures in general. They want to go back and rewatch it. That's probably something we should continue to do after the pandemic is over. Something that I worry about is they say things like, I would have survived, I do not think I would have survived Nick's labs without Nick. So I would really like the students to be able to do my labs without me having to look over their shoulder and answer every question. So somehow I have to figure out with all the combined information they're getting from videos and from the written instructions on the lab, how can I make that more clear so they're able to do more things with less assistance? These were the standard TEACHx questions that were added to every course. And in general, I don't find these very helpful, or I don't find this very promising. Basically, some of the students are really enjoying being remote, and some students are really not enjoying being remote. And I feel for them, this kind of hands-on learning is definitely not as easy as when they're in class. But I'm certainly hoping that more of them will want to do it, and we can find a way to teach so that these numbers would improve, so that we could serve more students. So some final thoughts on these TEACHx. The hands-on benefits we get from switching from standard lab classes to lab in a backpack style classes really benefit from face-to-face interactions with the professors, the TAs, and even the students talking amongst themselves. But to minimize the downsides of being remote, focus on providing very clear written instructions, good video demonstration, and being as open to as many office hours as you can. In particular, I found myself rewriting the labs over and over to get very specific in the written lab instructions without laying out exactly what they needed to do. There's a fine line there. Also, asynchronous content, I have been enjoying teaching asynchronously, but the students do not like it when I become a little more open with my due dates on their homeworks and when I will post videos. The videos can be very difficult to make, especially if you're a perfectionist. And you have to acknowledge that they'll never be perfect. You'll always stutter and slur and make some, poor writing on your screen. You don't need to start the video over for that, just erase it and keep going. But at the same time, you want to be clear, as in the first point. So a fine match has to be done, and it's really just probably practice. There's a lot more I could talk about here, and I'd love to. Please shoot me an email, nick.marchuk@u.northwestern, if you're interested. Thanks for watching.